Okay, I'm coming back with my live streaming. Alive na alive, si Junjun ngayon. Okay, in my science world. This is again your YouTube content creator and your science vlogger, social media. Okay, a while ago, I think a lot deeper and deeper. What's going to be my content today? Because today it's going to be until Saturday, and next week we will be stopping for another topic, and then this will be the last until Saturday in physics. So we may be able to solve 50 plus problems in physics as we calibrate our comprehension, and we need to check our comprehension, right? Okay. So I hope guys you remember all the topics that I discussed within this month. Okay? So I still have the last topics talaga, yes. Okay? But before going to that particular topics, the last topics, wow, diba? Okay? So I need to show you how to derive equation. This is the thing. Okay? Okay, because I need to find out what's the relationship between the electric forces, electrostatic forces with the charge densities, something like that. Okay, or surface charge densities like that of electrically charged particles. Hindi na naman. Electrically charged particles. Okay, kakaloka. Okay, this is how to. Well, somebody told me and recommended me it's good for you to become a high school teacher. My gosh, high school teacher in science and math. Oh my gosh, how to derive? Yes, really, I love. Okay, how to derive equation of electrostatic. We're gonna combine electrostatic and electric force because electrostatic is not moving between electrically charged particles, and then this electric force is gonna be moving. So it's partly related, right? The moving and not moving. Diba? Okay, electrostatic or electric forces. It's gonna be like that, right? Okay. So, ganon. Okay. So this is all about Coulomb's law, huh? This one, Coulomb's law equation. Coulomb's law equation. Like that. So Coulomb's law equation could either be electrostatic force equation and electric force equation. Then we need to derive this equation. Okay? So like that. So when we have a conductor, a conductor, okay, the material has the ability to conduct electricity, okay, something like that. So in that, we have various electric charges, something like that. And these electric charges have charge densities of different surfaces. Charge densities of various surfaces, meaning to say the density is not literally applicable to the fluid, liquid, and solid. For example, I have the density of steel, right? I have the density of the bronze. Okay, this is in terms of solid, right? So we can calibrate, or we can get, or we can obtain the density of solid if we know the specific gravity of a substance, right? Okay, we say specific gravity of a substance is equal to the density of a substance over density of water. So we need to say your density of water will always be at 25 degrees Celsius, your standard operating condition. And then if you have this specific gravity, then automatically you can get the density of any metals, any solids, blah blah blah, so and so. Okay, if it is not given directly, the density of solid is a problem. Okay, it has a specific gravity. Okay, but if nothing, then you have to scan with the different values in the tables and indexes in the physics books, chemistry books, like that, okay? With a point. Now we have also the density of liquid, okay? At certain temperature and pressure, okay? It could be liquid, gases, and fluid, okay, like this, okay? And then the definition of fluid can either be a liquid, okay? A liquid and a gas. So it's partly liquid, partly gas, okay? These are all fluid, including the solvent, okay? So the fluid is really general and broad, can be applicable to liquid, can be applicable to solid, solvent, sorry, solid kasi S ang start, so solvent and air, okay? In the air here, we have the moisture, okay? Air here, not the dry air we mean here. An air that has a moisture, especially a very humid weather condition. So this is gonna be a fluid in terms of the moisture in the air, okay? But if you talk about dry air, this is not categorized under fluid, okay? So the mean of fluid here is understood to have moisture, okay? Get the point? So liquid, okay, solvent, and an air, okay? Get the point? Ana na siya. Okay. Ang solid lahi siya. Now, if we have the densities of these substances, and these are all matter, right? Solid, liquid, gas are phases of matter. Okay? Like that. We have also densities applicable in electricity. So we need to say, it's not limited only to solid, liquid, and gas. We expand our knowledge, the technicalities of densities applicable also in electricity. Okay? And that is called surface charge density. Okay? Surface charge density. So we need to change our mentality that density is not only applicable to solid and liquid, solid, liquid, and gas. It's also applicable in electricity, in between the electrically charged particles, could either be static or moving. Okay? So, surface charge density. Ganon. Okay? So, because we have this surface charge density, then automatically we can have the current, okay, charge density as well. Okay? Ganon. Density as well. Okay? Ganon. Dito po yung mga palangga kong hitad. It's gonna be like that. Okay? So, muna siya yung hitabo karong higayon na. Okay? So, if you talk about surface, it has to do something with surfaces. Okay? Surfaces, not limited to area, perimeter, or linear, or volume. Okay? Something, these are all surfaces. Again, surfaces could either be in terms of linear or linearity, talking about the perimeter, sometimes also talking about the surfaces or the area, and sometimes also talking about the volumetric surfaces. So three, always like that. Wala na iskapo sa surfaces. Again, surfaces means linearity, mean linear, or talking about the perimeter of a certain geometric shape. And also, we can also say volumetric, meaning in terms of volume surface. Okay, for example, the most common is a sphere. It has also a volume, 4/3 pi r cubed. It has also an area of 4 pi r squared. Okay, something like that. Okay, so ganon. So surface charge density and current charge density. Okay, ganon. Ito po yung mga palangga kong hitad, it's gonna be like that. Okay. So now, as we progressing our discussion, we can understand what is really a current charge density. But before that, we need to discuss about surface charge density because ito ang pinaghuhugutan. Okay, this is the source before coming to the current charge density. Okay? Because the electrons will not flow, will not create an electricity if those particles are not electrically charged. Okay? Like that. Something like that. You get the point, mga palangga ko? Charot. Okay. Now, surface charge density, what is the definition for this? Okay, anybody? Hi, shout out to Sir Jeremy Sibelius. Thank you so much for listening for a physics discussion. So what is a surface charge density? Okay. 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 This is really talking about the amount and quantity of charges, again, amount and quantity of charges, okay, that is, or that are accumulated or distributed, okay? Distributed is just the same. You can change the verb, the action verb, as long as you know that it is the amount and the quantity of charges. Your clue is charges, and here is only English here, somewhere along the way here. Accumulated, distributed, generated, like this, induced. So many the same adjectives will be here. The important is you understand really what's the main point, okay? That accumulated and distributed, generated, induced, like blah, blah, blah. Okay, through, okay, surface, okay? And surfaces can either be linear, okay, area and volume, okay? So like that. You get the point, mga palangga? So that is the definition of a surface charge density. So if we have linear, okay, area and volume, so we can also say 8 types of surface charge density. So I could say directly, based on my definition, I can create 3 types of surface charge density, okay, like that. So what are the types? So it's very obvious, right? We have the linear charge density. Okay, linear charge density. Okay, all you have to do is to look the root word, something like it's a linear charge density, like that. You only describe what type of charge density is that. Okay, and then area. So you need to say surface area. Okay, charge density. Okay, like that. And then we have also volume. So volume charge density. Okay, volume charge density. So the charge here is electrically charged particle. Okay, so that you will understand. Okay, now surface area charge density, sometimes only called area charge density only. No need to put surface, but most of the times they put surface talaga siya, surface area. Okay? Because since we know these are all surfaces, but actually, we put really a term surface area. Charge density, okay? Not the same with the linear charge density and the volume charge density, but these are all surfaces. Okay? Ganon. Now, we need to introduce formulas for each. Okay, introduce formulas for each, mga palangga. Okay, we go first to the linear charge density. So, ana. Okay, so ana kano. So, surface charge density. Ganon. Okay. Charge density. So, let's forget a little bit with the understanding that density is equals to mass over volume. Forget a little bit for that, in this topic of related to electricity. Okay, so surface charge density, 3 types. First, linear. Okay, charge density. Okay, what is the formula for this? Linear charge density. So you're gonna be, let's say, what's the call this one? Omega, like this? Omega L is equal to, okay, the charge or electrical charge. The unit of charge, but understood to be electrical charge or electric charge. It doesn't matter. But charge is general. Okay, term. And then over, okay, charge over, this is linear, over L on D. Meaning this is the distance, the length, something like that, okay? So C over L. Now we go to the surface area charge density. Surface area charge density. So your clue in your memorization will be charge density. And you need to put an adjective describing what type of charge density is that. And that adjective seems to be the geometrical shape or surface. Okay, geometry, something like that. So the surface area charge density, omega, so let's say surface area meaning SA, surface area. Omega SA is equals to the charge per area siya. Because surface area charge density naman siya. So what changed here is only the denominator. Okay, but your charges will always be in the numerator. Another technique also during memorization. Okay, number 3. We have the volume charge density. Okay, like this. Okay, and then omega volume or V is equal to C over volume na siya. Now, your linear area and volume. Linear is very easy. It could be distance only in meters. Meter is the standard unit of length in metric system, or is a unit. Okay. Then the feet will be the standard unit in English system. Okay, like that. Now your area will be considering here the common, which is the surface area of the opening of the pipeline, like that, or any circular opening. So this is gonna be m raised to the power 2. Okay. Surface area. Get the point? Because there's a lot there siya. Pero the unit will still be m over raised to the power 2. Okay? Usually. Okay, whether it is a square or a rectangle, it will have a m raised to the power 2 or meter square. Okay. The volume charge density will be, the volume is cubic meter also. Okay. The usual example for this is the volume of a cube. Okay. Cube. Perfect. Equal. So this is width, okay, length, width, length. This is the length, the width, and the height. So volume is equals to width times the length times the height, and the height is equal automatically to thickness. And so you change this with T. In this case, because they are both the same, equal. So it's gonna be meter times meter times meter is equals to cubic meter, because each side have equal measurement in a cube, like an ice cube, like that, or a dice. Okay, like that. So ana na siya sa cubic meter na siya. And now in the derivation of the equation, the electrostatic force or your Coulomb's law equation, we need to consider the surface area, not the linear and not the volume. Okay? Like that. Okay, now, how can we do that? Okay. How can we do this? Thank you so much for watching my Mr. Rivera, for passing by in my FB live streaming and simultaneous YouTube and FB live streaming. Okay, like that. Okay, mga palangga, kung hitag. Okay. Now in this topic, you're gonna remember also the constants. Okay, the specific constants of, it's gonna be the K, which is okay, this is electrostatic force constant. Okay, it is also called as electric force constant. Okay, and it's also known as the Coulomb's law constant. Okay, so which, it refers to the same constant, and the value for this, some books says it's 8.99 times 10 to the 9, something like that, and then Newton meter squared Coulomb squared. Coulomb squared is capital C. Okay, equivalent to 9 also, to make it perfect. 9 times 10 to the 9 with the same unit. Okay, because it depends on the books you are using, or the reference you are using. Sometimes you use the 8.999 and sometimes also 9. Okay. Now, and it also take note also the another K, which is the permittivity. Permittivity constant through space. Okay, ganon. So, kasama niyo siya mga palangga kong hitad. We can also derive this K, okay, by showing you the totality of the derivation. So, permittivity constant through space, like that. So, what's the value for this? It's gonna be 8.85 times 10 to the negative 12. Okay? Then, take note, the unit of your Coulomb's law constant will be the reverse for this permittivity constant through space. It's gonna be Coulomb square, okay, Newton meter square. So, during your memorization, okay, the permittivity constant, the unit will be just reversed. So, it's easy for you to, to remember. Okay, like this. We have 2 Ks now. And this is the popular one, the first, because this one is will take time to compute. And this one more direct. I'm just showing you how it is being obtained, something like that. Okay, now we go back to the surface area charge density. Okay, like that. Now, if the question will say, what is the purpose, what is the charge density all about? Okay, so meaning to say that is electric or electrical. So, wala gibog ang puro understood na. That charge just refers to electric charge or electrical charge. Okay, like that. Okay, so through the definition, you can understand what it means and what's the purpose, what's the objective, like that, blah, 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 so and so. Okay, now we have to choose the type 2, the surface area charge density, right? So, lingwa kanisha. Okay, omega S is equals to the charge over area. Okay, charge is general, right? Okay, charge is general. Okay, now charge can be written also as Q. Okay, over area. So, charge is Q in symbol. Okay? Again, Q is hypothetical. So, what's hypothetical? It only represents what it means, but it doesn't relate in actual. Just like I can put anything here, as long as I refer this as a charge. Because sometimes also this can be known as a heat energy. Sometimes, okay, but the capital Q is more popular, but sometimes the small q also. Okay? But in here, the small q is the charge. Okay, just like in the formula of current, right? Current in ampere, capital A is equals to the charge Q over time. So therefore, 1 ampere is equals to 1 coulomb per second. Okay, things like that. And then 1 coulomb is equal to 1 ampere second, like that. Okay, so if you know the formula, then you can exactly, the units. Okay, like that. So we have this equation number 1. Diba? So we need equation number 2 also. Okay. So based on my research, I really researched this because this is quite complicated because, when I took up practical electricity in my engineering education in Cebu Institute of Technology University, we did not tackle a lot to go into the details of practical electricity because we are not majoring in electrical engineering, right? We are introduced only with the Ohm's law, like that, so and so, the Kirchhoff's law of, what is that? Parallel circuits. Because Ohm's law normally in series circuits, and there's also another law, the Kirchhoff's law, right? If you can still remember, I don't know, the series and parallel, something like that. It's stopped there. But beyond that, no more. That's why I keep on researching also because it can be applied also, okay, to another topics of physics. Okay, like that. So if you are really wants to take master's major in physics, NS physics, then it's about time to listen also these kinds of labs, okay? Because the ordinary or the regular physics would not be enough. Okay, the physics lecture 1, physics lecture 2, there are still additional, the white complex, you know, like this. This is now quite complex. Okay, but the theory is quite complex, but you know, when you solve, it's not really that complicated. Right, really, I will show you later on. Okay, like that. So it's gonna be like surface area charge density omega s. Omega is a Greek word, huh? From Greece. Okay, there are a lot. For example, rho. Okay, rho, theta, phi, epsilon, mu. This one, omega. So we have omega fatty acid, omega 3, good for the heart. Tuna, century tuna or tuna fishes are rich in omega 3 fats, something like that, good for the heart. So that's why you have omega. Okay? Like that. Okay. Now this is the ratio of your, okay, naon mo siya kanong higayon ng mga palangga kong hitad. Okay? Okay. So naman natin equation 1, no? Marino, ang ating equation 2, since we are referring to electrical energy, and then there's always electric charge, blah, 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 so and so, then we go back to the electric field. Guys, because if there's no electric field, guys, how can the force act between the electrically charged particles in order for them to move or to accept the charge? Okay, when they're activated in the law of, what do you call this one? Law of magnetism and law of polarity, something like that. Okay, so there must be an electric field always. Just like a magnetic or law of magnetism. If there's no magnetic field, and there will be no magnet at all, because there's no region to take place the magnetism process. Ganon. Okay. So kaloka. Parang na yung sabi. Okay, electric field. Electric field is equal to the electric force, or you can say electrostatic force. Okay, pareho naman siya in this situation. But we need to choose electrostatic force lang, ha? E pa rin. E, F, E, because the first letter E of electrostatic is just the same, and the first letter E of electric, right? So F, E over Q. Q is a charge also, ha? Mga palagakmitan. Okay, equation number 2, like that. Now, how can we pasok sa banga the relationship of this surface area charge density? Now, you need to correlate the surface charge density with your permittivity constant through space. So, by my own research, I really researched for this in order I can understand, because there are automatic formula in which I cannot understand. I have to dig it up, where it come from, like that, and then I really troubleshoot. Oh, it's gonna be like that. Okay, so it's gonna be E is equals to the, okay, it's gonna be this one, omega S. Omega S is your surface charge density over the epsilon O. Diba? Greek term again. Epsilon O. Epsilon O is your permittivity constant through space. Like that. Or you can say permittivity constant only because it takes a longer time for you to memorize the whole thing. But for me, I love to say permittivity constant through space because medyo ano siya, vonga, something like that. Okay? So, it's gonna be like that. So we have the equation 3. Okay? So would this be enough to derive the equation of the electrostatic force between electrically charged particles at certain points? Something like that. Okay? Pwede na ba o hindi pa? Charot. Okay? I think pwede na siya, no? Okay. Anak. See, ganon. Okay, starts the derivation. What's common here? The E. E. Okay? Like that. So equation 2 and 3. Okay, equation 2 and 3, meaning you are assuming that your electric field will be constant somewhere along the way, or will act uniformly That's why you need to equal this for the moment, something like that. So that's really the concepts of most of science and most of mathematics during derivation. You need to assume that then it's gonna be like that. Okay? So you get the point, mga palangga, kung hitad mo na siya natabo na ng higayuna. Okay, now, forget a little bit the other version of electric field is equal to the voltage V over the D, which is the length. Forget a little bit the other version because this is in terms of voltahe. Okay, voltahe na ni siya, not really the charge. Okay, like that. Then I can also derive another equation for this that could relate only to the electric field and the length dropping the voltage. Assuming also the voltage is constant somewhere along the way. Meaning no variable or there's no variance or changes of the voltage. So we can compute point 1 to point 2 later on. Okay, but first we need to do this. Okay, equation 2, the value of electric field is equals to the electrostatic force Fe over Q. Oh. And then equation 3 is, okay, this one, surface area, charge density, like that, over Q. No, it's not. Over EO. Okay, the permittivity through constant through space. Oh, this one. Now take a look, okay, in your other equations above. Can you still substitute the common, something like that? Yes, I have the surface area charge density, which is Q over A, and I will substitute that in equation here. Okay? So, let's say this is your equation 4. After equating 2 and 3, so equation 4. You will say, substitute equation 1 to equation 4. It's gonna be so. Electric force is equals to the charge Q is equal to the charge, but still the same with Q over A. So, Q over A, like that, over the permittivity constant through space, like that. And then after that, we are here. Then guys, I don't love the multiplying to something in order we can cancel it out and simplify the equation. I don't love that kind of attack. I love crisscross multiplication technique in math. Okay, crisscross, like if put an x, the x will be your direction where to multiply. See, if I go like this, then you have to multiply that there. So Fe, electric force times the permittivity constant through space. So Fe times the epsilon O. Okay, is equals to Q over A times Q. So Q over A times Q. Take note, you cannot cancel the Q because both the Q are in the numerator. See, the whole Q. So you cannot say, you cannot cancel, okay? Because nagdali ka, because you're taking fast that your equation will be simplified, and then there is the same letter, then you will try to cancel, okay? Like that. So this is gonna be Fe epsilon O is equals to Q squared over A, right? It's gonna be like that. Now, this Q here represents, as I told you in our previous topic, is it's connecting the dots talaga siya when you derive. Connected to other basic concepts also. You see about Q here, guys, this is more general. It talks about the source charge in column and the test charge also in column. The test charge will be variable and the source charge will be your main source of charge. And then the main source of charge is represented also with capital Q. Okay, so you need to break this into capital Q times small q. It's generally equal to Q raised to the power 2. Okay, so it's gonna be F-E-A-O is equal to capital Q over the small q over A. Okay, now let's transfer this in the another side. Oh my gosh. Oh. Okay, so it's in here. The technique of derivation is you have to be patient. You have to be patient and you must keep your momentum that you are really going to the direction logically. Okay, logically meaning interconnected with the concept and theory. Di magpataka. Something like that, okay? Fe, like epsilon O is equals to Q. If you are trying to derive not related, if you do the same formula, it's not also viable or doable, something like that. Okay, so your execution will lead to error, something like that. Okay, so we have now like this. Okay, we have very clear, right? Okay, now we need to compute for the Fe na lang siya. This time, guys, I don't need to use the cross multiplication technique in algebra because this one on the left side has no denominator. This is understood to be 1. It's okay also to use cross multiplication, but this time I will use the multiplying to something in order we can cancel so that we can have the quantity we are trying to ask. What's that? So this is divide 1 over EO because you're trying to find the Fe, your target in your derivation. You need to get and obtain the formula of electrostatic force equation or the Coulomb's law equation. We need to derive this because this is not a magic. Okay? May pinaguhugutan where this formula came from. Okay? It's gonna be like that. So, like that. So, FEO times 1 over EO, cancel ang EO. Talaga. So, FE na lang. Muna siya kung multiply ka to something para simplify. I don't like this, but let's try. Charot! Okay, so Q over A times 1 over EO. So, capital Q, area times epsilon O. Ganon. Diba? Nakakaloka. Now, take note, mga palangga kong hitad. Okay. In this topic of derivation, as I told you 1,000 times, 100 times or 1,000 times or whatever, the volume of a sphere is really popular in physics. This Albert Einstein, Isaac Newton, Johannes Kepler, Michael Faraday, John Maxwell, okay, Mr. Coulomb, Mr. Ampere, something. These are the scientists, right? And then, okay, Mr. Coulomb's also, and a whole lot more. They usually use the geometrical shape of a sphere because the sphere is a shape that is tantamount to the universe. Okay? So that's why they use always the sphere, not the circle, not the rectangle, not the rhombus, not the parallelogram, something like that or whatever. Use always sphere, and sphere is very popular in math. Even though in integral and differential calculus, there's still sphere as a sample problems. Always. Integrate. Charot. Okay? Module na siya predict ang sphere. Ayun yun. Makalimutan pa ninyo ang uban ay lang na ang sphere. Okay? You got the point? Ganon. Okay. So, pwede ang triangle dito, ang sikat na triangle, pwede mo siya gamitin good 1/2 base times height ng triangle, right? And then parallelogram is 1/2 what's that? Base 1 plus base 2. Then gano'n. Nakalimot ko sa parallelogram, but I'm sure with the triangle because it's easy. Okay, 1/2 base times height. Okay? Muna siya mga geometry. Okay, like that. Okay, now we have now here. So electric force is equals to the capital Q, which is your main charge or the source charge, times Q is your test charge. Okay? Like this, and then over the surface area, okay, because we are using the surface area charge density, right? And then times epsilon O, something like that. This area referred here is the sphere, okay, S-P-H-E-R. Again, that's why we have atmosphere, lithosphere, hydrosphere, okay, exosphere, a region in which is very hot, nobody will survive. Okay, like that. And we have the stratosphere, the region where our airplane will be staying in the sky. That is the region. Okay, lithosphere, gano'n, hemisphere, blah, 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 so and so. Diba sphere, permi ang ipuno. Okay, sphere. Muad lang kang prefix na something, i-add ang sphere. Because sphere is really the basis of all. in pure sciences. Okay, like that. Okay, sometimes cube, but sphere really is more popular. Okay, like that. So, what is the volume of a sphere? Check comprehension, stack knowledge. V is equals to 4 over 3 pi r cubed. What is the area? 4 pi r squared. Now we use this 4 pi r squared. Substitute that here. Okay. Electric force is equal to the capital Q to the small q, where the area is 4 pi r squared. Okay. Times epsilon O. Okay. Like that. You get the point? Mga palangga ang hitan. Okay. Now, you have now the r squared here in the denominator. Take note. This r squared here will be not your radius. Okay? It's your distance. Okay, since you have two charges here, let me explain. So I have two charges here, capital positive charge B, big circle, small circle, and the other side with the small positive. Okay, so the small positive is your Q small, and your positive circle is big is the capital Q. And if you measure this R, this is from the two centers of the masses of your charge in the centroid, or in the center of gravity, CG, like that, right? You always have the centroid in your computation when you erect and you build a bridge. The centroid is very important, okay? Because if you will not consider the centroid, then it will not evenly distributed your loads, and then it will collapse somewhere along the way, your structures. So you must consider the centroid, or the center of gravity of these two objects, of these two charges. It is in the center. So I will connect an imaginary line until to the center of the other one, the smallest one. This is your R. Okay? This is your R. Meaning, the R, the radius here, only emphasizing that it's in the center. Because in the center, it signifies also the radius of half. If you try to rotate this in a 360 revolution. Okay, but it doesn't mean literally that is the radius you are here. Okay? You get the point? Yan atong pagsabot, because usually R will refer that as a radius. Okay? For example, in a cylindrical, whatever shape of a round pipeline, something like that, the area is equals to pi r squared, like that. Area is equals to pi d squared over 4. Because diameter is just equal to 2 times the radius. And through derivation, we can have two versions in terms of dia and in terms of radius. Dia is the same as radii, another term. Okay, diameter is the same as radii. Okay, radii is equals to 2 times the radius. So meaning to say, the plural of radius is radii. Okay, or diameter. Okay, it's not popular ang radii, popular ang diameter. Just like fungus and fungi. Like that, okay? Fungi is the plural of fungus. You get the point? Things like this, alumnus, alumni, something like that. Okay? So plural ang alumni. Okay? Things like this. Bacteria. Okay, bacteria is plural, bacterium is singular. Okay? Because most of the times, bacteria will exist as a group. Then it's seldom and it's rare to find only one bacterium. That's why normally we generalize them as bacteria. But if you can only see single, that is bacterium, not bacteria. Because the singular of bacteria is bacterium. So bacteria is so many. By nature, there are so many also. That's why we will not always use the word bacterium. Okay? You get the point? Just like criteria and criterion. Criterion is only one criterion of judging voice quality only. That is criterion. Okay? But criteria, so many. Voice quality, timing, diction, that's criteria. Okay? In English. A little bit English tayo review. Okay? And then we have also the collective noun. Be careful with the collective noun, The collective noun naman palangga is the singular form will be just the same in the plurality. For example, if I have let's say, menu. What is the food menu? You will never say food menus. Okay? You will never add S in the plural. It's still menu, whether singular or plural. What else? Example, equipment. Equipment is also singular, is also plural. You will never say equipments, that's wrong grammar. Okay? You can never find in dictionary the word equipments. Okay? You can never add S because that is collective noun. Okay? What else? Analysis. The rule of analysis in English is not the same with the other one. The singular is analysis, the one we're always using. I have an analysis that's gonna be like this, but if you have so many analysis, it's not longer I in the second last word. It will be analyses, the plural of analysis. Okay, be careful also. Though we are not using this, this is not too much important, but at least we know. For example, if you're working in a in a journalism industry, in a books industry, in a printing industry, so we are very careful also because we are dealing with words, terms, writing an articles, news, or something like that, blah blah blah. If you would do the report also and you publish that in the public, then you should be careful because it is accessible to all. You're the author, so this time you'll be particular with the collective noun. Okay, so in a way, when you speak, you are safe because it's the same, but only when you write. Okay, analysis and analysis. Okay, when you write, the plural is I have. And then, the plural is ego, and the singular is I. Okay? Ganon. So, muna siya mga kuan. Kato pong mga lose ha, lose, lows, and loss. You should also distinguish this in English. These are homonyms. The same sound, but the same sound and rhyme, but different in meaning. So, lows, lose, loss. Okay? Different meaning. Okay? Like that. Okay. Ang luag kani siya, L-O-S-E. Okay. Ang nawala kaning dubli ka S. Ganon. Okay? Mo ba na? Correct me if I'm wrong, because I'm not majoring in English. I just love in English. Okay? I just love English. Okay. Now, we have the R here. Okay, right? Then you can apply that here in the denominator, okay? Something like that. Now, we can simply say that we need to transpose this r squared to the beside with these quantities 4 pi and EO. Let's say FE is equals to Q over 4 pi epsilon O r squared. Now, this 4 pi epsilon O, it's in the denominator, right? And it will become 1 over 4 pi epsilon O. So you need to put that on the other side. This one. Fa is equals to 1 over 4 pi epsilon O times capital Q times Q over R squared. Now, this is the time that your 1 over 4 pi EO is also your permittivity constant through space, like that. And this is now equal to your K. Okay? You get the point? So this is by experimentation already. This is not by derivation, but experimentation by our scientists through several readings like that. Reading 1, reading 2, reading 3. And so they can have this constant. Normally, constants can be through experimentation, just like Arrhenius equation in chemical kinetics and Michaelis-Menten equation, if you can still remember, right? And also Pugnali equation, right? The rate law equation, the chemical reaction rate equation in kinetics. Okay, something the first order, second order, third order, something like that. Okay, now, muna siya nahitabo. So this is your K. Now you can substitute the K directly here in the side. This is the same, or we can use the value of epsilon O, which is the permittivity constant, so that we can get the K, which is now the 9 times 10 to the 9, gano'n, di ba? Okay, Newton meter squared over c squared. So, this, may pinaghuhugutan talaga siya. Okay, so K is equals to 1 over 4 pi 3.1416 times the permittivity constant EO is equals to, as I told you a while ago, 8.85 times 10 to the negative 5. Okay, since this is, okay, Coulomb squared, Newton meter squared. So it's very obvious, right, that when you reverse one, the unit of your K will be Newton meter squared over c squared, which is the unit of your electric constant, or the Coulomb's law constant. How much? In here, we already get the constants by having the derivation, right? Okay. Our only difficult part is here. K is equals to 1 over 4 pi times epsilon, because we cannot do magic here. Okay, we cannot do theory. We can do this by experimental data. Okay, experimental data in the laboratory by our previous scientists. Okay, this equation. All you have to do is to memorize this. Kailangan naman experiment pa kagbalik. Okay? So you need to memorize this so that you can derive. Okay? No more time to prove. Okay? Because mahal tayong oras and there's no laboratory in my room. So, okay. Like that. Physics laboratory, it's not chemistry lab. Okay? So, be sure that your answer will become 8.99 times 10 to the 9 Newton meter squared over c squared, because if not, my derivation is wrong. Okay. So, 8.85 to the negative 12. Negative 12 na pala akong hitad. Negative 12 is pico. 10 raised to the power negative 12 is pico. And then when I Google search somewhere along the way, because I forgot, because sometimes our memory fails because it was 25 years ago, right? Though we memorize and accumulated our brain, sometimes we are in doubt, right? In the benefit of the doubt, also, we need to confirm in the Google search. Okay, there's no perfection in the world, right? No need to explain, that's reality. Okay, when you check the Google search also, napataka lang po ng Google search. Okay? Yung pecto dito, 10 to the 12. Siya, pectofarad. Farad is the unit of a capacitance. Okay, what is a capacitance? The process of storing energy in the form of electrical force in an electrical field. Something like that. And through the use of a device called a capacitor. Okay, a capacitor will store electric current and electric energy or electric charge. So this is a device. Without this, there will be no electricity because nobody can catch or nobody will act as a medium in your creating of your electricity. Something like that. So you have the conductor, right? It has an electrode. Okay? Electrode. So meaning to say you have the capacity of your capacitor, of course. You have your plates, capacitor plates, or electrodes. Okay? So electrodes mean either anode or cathode. Okay? Yun na tayo mag-review ito mga konsipat. Negatively kasi naman kayo. Okay, so like that. So pectofarad. So Google search is wrong. Okay, I found out so many wrong in the Google search also before. Chemical composition of magnesium oxide, nakataka lang. Okay, and then so many things. Okay, but so many correct, but only small wrong because there's a lot of sources also, right? Okay, so it's gonna be like that. So what I mean, don't trust in one source only. Okay. So 8.85 exponent to the negative 12 times 3.1416 is equals to times 4 is equals to. Memory recall. Okay? Memory recall, memory in, ha? Ganon. Scientific calculator. Okay? Times 10 to the negative 10. Okay? Kasi makabukod sa calculator, chart. So 1 divided by 1.112 exponent to negative 10 is equals to, see, 8.999 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 10. Actually, the correct really is 8.99. Guys, better not to round off, huh? Because the actual really is 8.99. Okay? K, your Coulomb's law constant that can be substituted in your electric force equation is 8.99 times 10 to the 9. Okay, Newton meter squared Coulomb squared. Now, after this is the K. Finally, you can have the equation of your electric force or electrostatic force is equal to big Q times small q over r squared times the K on the other side. This is now, so you see this in the books. This is the final outcome after the series of derivations. Okay, so electrostatic force or electric force is equals to K. The K there is your Coulomb's law constant or electric force constant or electrostatic force constant times the big Q, which is the main charge in Coulomb or the source charge in Coulomb, times the small q, which is the test charge, still the same in Coulomb, and then over r squared. Okay, like that. Now, if you have only one charge, guys, equilibrium, because you can also substitute that again, go back to the electric field. Because sometimes also the problems have only one charge and buumot na yun ka. It's not like that. You should also remember the other equation. Okay, usually. I will share this to you because this is my mistake in college. Okay, I will share to you. I failed this to account. Really. So, if I could say like this, it's not pala enough, you try to dig back, okay? So, for example, if there is only one charge given, there's no test charge. Your main charge will also act as your test charge. So, meaning you have only one Q. How can you do that? You can still solve that. Don't assume. Use also derivation. Okay, electric field is equals to electric force over the charge Q. So electric field is equals to the electric force, which is this. Substitute that here. So K times Q times small q over R squared over Q. Now cancel the small q. What will be left is the charge, capital Q. So electric field is equals to K times the capital Q over the R squared na siya. So in this case, you can solve by having only one charge, not two charge in terms of the electric field. Okay, like that. Get the point mga palangga kung hitad, ganun talaga siya. Okay? Now, if there's no given with the resistance, then go to the voltage. You can equate this also to voltage over distance. Like that. And your distance is also your R, right? So, voltage, cancel the R here. So, voltage is equals to the electric force constant times Q over R squared. So, you can also compute in terms of voltage having one charge only. Do not be afraid because usually the problem is asking for the charge, the distance, like that, blah, 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 so on, so electric field. And this time, the problem is, what is the voltage? Oh, diba? What is the voltage of two electrical charge that will pass the point A to point B having a charge like this, blah, 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 so on, so, with a radius like that. Then, itumalagkalit ang voltage. Oh, mo-derive ka. Okay, because in the books, it's not being combined by siya. Okay, so we need to say, in this discussion, I anticipated. Okay, I anticipated to teach you, if the problem will ask for the voltage, then try to equate that to this equation, the original equation, because there is also another version of electric field is equals to the voltage over the distances. The distance and the radius is just literally the same. By concept here, it's just R. It's not literal D. Okay, so this will be cancelled somewhere along the way, and we can drop. Okay, we can drop the electric field and we can compute for the voltage. This is assuming that your electric field also is constant somewhere along the way. Another problem, if the electric field is uniformly not changing, what is your voltage in two electrically charged particles having 2.0 times 10 to the negative 6 micrometer and a distance of 0.2. Pasok sa banga. You can compute now your voltage. Okay. Ay, pag sa liga itong voltage is equals to I. Ara, kalayo na kayo itong current. Huwag mas na siya resistance, di mo, mabuang ka. Okay? You get the point. Though maabot ra ka sa I or sikag ka ng, you will continuously derive, but it will take you how many days? Imagine from resistance from here, there's no resistance quantities here. Check. Maybe when you get the voltage here, because I say voltage is equals to KQ, and that's the time you will connect to the VIR here, right? Because the voltage, nilusot naman siya ang voltage. Ana na siya. Muna makapindot din ka sa resistance, kaya naman siya voltage, ana na yun. Diba? But, assuming that your electric field is constant somewhere along the way. Okay, hindi ka magpataka o equate. Ganon. Okay? Ganon siya. Any questions so far for the derivation of electric field, electric force constant? Okay? Electric force equation, the Coulomb's law equation. Okay, ganon mga palangga, di ba? Any questions so far? Magkakaroon ako mga example. Okay, like that. And now my last question will be, who proved that the world is round? Who proved that the world is round? It is Christopher Columbus who proved that the world is round. But it was not really round now. It's a little bit of elliptical. It became flattened due to the climatic change or the climate change due to the presence of greenhouse gases, okay, in our atmosphere. So it's not really the circle one. It's a little bit flat like an ellipse, our Earth. Something like that, not totally circle. Okay, like that. And our planet Earth is already 3 billion years old plus. 3 billion years old plus. Very old planet we have. And we must take care. Okay? We cannot reach 3 billion years old, but our planet Earth now is 3 billion years old plus. I don't know the plus, but generally 3 billion years old. Okay, that's the age of our planet Earth. And now, what is the mass of our planet Earth? 5.97 times 10 to the 24 kilogram. Okay? And what is the radius of the equator in our planet Earth? That is 6.38 times 10 to the meter times 10 to the 6 meter. So this is the radius. This is our constant. It will never change. Okay? Because it was done experimentally by isang tuwi na kalimot ko, Johannes Kepler. Okay? And magkumbay-kumbay na mo nilang mga theory guys. Uy, sila si Albert Einstein, Johannes Kepler, Isaac Newton, ug si Kuan katong usa, nakalimot ko si pangalan guys ko eh. Katong nasya Kuan. Basta. Okay, nakalimot ko. Okay, thank you so much for watching John Gabriel and Ma'am Janet Sadeliano. Shout out. Ay, classmate ko, commander na naman si Ma'am Janet Sadeliano sa CAT. Okay? Na ako po ang major S5. Charot! Okay. Because we have the corps commander S1, S2, S3, S4, S5, and we are on the front of the whole, you know, ano tama na guys? Kanang nakalimot ko sa term sa sa CAT. Kanang usa ka ba batalyon. Inang sa tubangan. Okay? Di ba, platoon leader, captain, and then ganun. And then the S1 will run there in the center and will shout something like that, and we will have our formation in the front. Okay? Something like during the fiesta of Francisco de Assisi, the Saint Francis of City of Naga, Cebu. So the Naga National High School and the Shen School of Naga will execute the, you know, what they call this one, drum and bugle corps presentation, something like that. But it was lost na, okay, when the Dilawan take over, Dilawan, okay, meaning the Kakamping. They tried to eliminate that. This is the law of President Idralin Marcos Sr., the father of Bongbong Marcos, the president we have now. So the projects of FEM is very, very good. But when they turn over, they remove this CAT and ROTC. This is very, very good because this is to train our people to be active in terms of how to do the self-defense in terms of a warrior or war, something like that. Then this is very good for girls also, right? Because somebody will rape them, then we can do a lot of technical to fight also the one who will rape them, something like that. So then the first that will be very good to that is the discipline. Okay, they teach discipline in military forces or safety discipline, and then teach you to what do you call this one? Alertness of mind and mental and physical alertness. Okay, mental and physical alertness. So this you how to think quickly and how to act quickly and how to solve quickly in terms of any insurgencies or any emergency. So this is also part of the purpose of ROTC and CAT. Okay, and then the discipline will be there will be push-ups. This is to train you how to accomplish your goal with loyalty. Okay, we will start in that way. So we have to have loyalty to our country, to our government. That's why so many communists are in pain because they lost already the CAT and ROTC. Okay, because our high school and college students have this, it's being taught there that we should love our country, we should patronize our own products, we need to establish loyalty to our laws, like that. We should be a law-abiding citizen. Since that was lost so many years now, that's why so many rebellious acts, protest there, the young students will go there because this has been lost. RTC and CAT, so the discipline has been lost already. And this is the foundation. Right? That's why the Vice President Sara Duterte introduced this program again, so that these protesters will be reduced because they understand now how to love our country, how to be a law-abiding citizen, something like that, to contribute good things to our country, not to be divided. We will be acting unity to make our country great again, something like that. Okay? So very good. Yes, the discipline, right? Discipline, alertness of mental and physical, like that. Then loyalty, okay, like this. Okay, ganon. So mo lang siya ang pinaka-basic na gusto na itong makuha. And then, self-defense, okay, like that, okay. And the last but not the least is to establish bravery. Okay, establish bravery that we should not be afraid. Even if we lost our life to the expense of our family, to the expense of our country. Okay, this also being taught in our ROTC and CAT. How important this. Okay? But the young minds of today, they cannot understand unless somebody will educate. Ano kaya educating you? Right? This is my avenue to educate you through my platform as a social media influencer. Right? And this is part of my, advocacy. Though I am really doing the science lab because I love science, because I am a licensed chemical engineer, okay, related to science is my profession, then I have also to have a small bits of political issues, yung ganon, di ba? Okay, muna siya, guys. So we need to be grateful to our Vice President Sara Duterte, okay, for this. It's very good. And I remember also our training before, so too much. It teach you something that you will live in a simple life, like that. To train you like that, to walk in the cable, something like that. Very, very difficult training in the in the CAT, something like that. You have to swim in the river, like that. So many things. And then if you will pass that one, then you will now become CAT officers, something like that. And there will be also exam like that. There's a lot of teachings also, lessons also. You also know how to use the compass again in terms of, for example, war, and then if you lost and in a mountain. and you can determine where are you through the use of the compass, your direction. It's being taught also in CAT training. Okay, compass, north, east, south, so that you can easily be located from your friends. You will be lost, and then you will be captured by them, or they can save you if you are get lost in the wilderness. Wow, wilderness, forest, something like that. So really, it's really good to have this kind of training, CAT and ROTC. Okay, perfect. Okay, something like that. Kung ito bright si Kuan, si Cory Aquino, he is not brilliant as Ferdinand E. Marcos Sr. Okay, mura siyang bubuon. That's why. Okay, you get the point? Then, yan, medyo gawin si really, you remember she had a speech and then attacking Juan Ponce and really. And her statement is more like a general statement, only a generic statement, not referring to the law, no technicalities, opinionated, just like a plain housewife talking in the microphone. Meaning, she did not attach with Republic Act, she did not attach with technicalities when she say something. Basta lang kayo makasulti siya, mga ni sinabihan niya si Juan Ponce and really, huwag kang magpakababae. This type of sentence is not really a good leader, meaning lack of intelligence and knowledge. Okay, mga kuwan siya mga chika-chika sa kilid-kilid, sa kali-kali. Ano ang style ni Corazon Aquino? The way she would have speech. Okay, listen to her speech when she tried to, what do you call this one? Toppled kasi ba, or overthrow Ferdinand Marcos Sr. Look, try to listen her statements. Okay? Kung ano kayang mga statements mabaw. Okay? Superficial. You get the point? Ganon siya. Iwan ko, bakit namatay siya kaagad? I don't know. Okay. Bakit kinuha siya ni Lord? Kasi patanggo yung mga kasalanan niya. Diba? Trying to be good in public, but then deep inside, meron ginawang, diba? Because according to the intel, it's also the family of Aquino who killed Ninoy Aquino. That's why they don't fight for the justice of Ninoy Aquino, because it's gonna be her cousin, her brother, her blah blah blah, so on so see. Imagine how I cannot explain further. It will take me many days to explain to you so that you will believe. Nakakaloka. Okay. Ganon. So, okay. Muna siya. Nasagtan na itong tanan guys ha sa atong physics theories and problem solving will be done later. Mayroon sa coffee to activate my brain cells. Okay, thank you so much. If you love this video, I'll be exiting in my YT channel, but I'm still having my FB live. Thank you so much, guys. Okay, bye-bye. God bless everybody. See you later. Oh my God. Hi, nako.